All right, you guys, good morning, and today we are going to cover Chapter 20, the last piece of information you need to know. So I need you guys to get out your Chapter 20 study guide packets. You're going to turn to page 9. So you're going to turn to this page right here, and we are going to finish pretty much your packet. Since you had homework the other day, we should be able to finish it. And you have this in case I go too fast. You can go back and listen to this lecture again. So let's go ahead and get started. So today we're going to think about when you're at home and you use water to help clean, like let's say if you ate some food, you would use water to clean off your plate. If you have to go to the bathroom, you would use water to flush the toilet after you go poop and pee. And all of that pollutes your water. And so we're going to talk about today, how do we treat that water that has been polluted? And it really depends on where you live. If you live in town, such as urban, or if you live out in the city, such as, not in the city, I'm sorry. I meant to say you live out in the country, that would be considered rural, or suburban, depending if you live a little bit more on the outskirts of the city. And you would use different ways to treat that water depending on where you live. So that's what we're going to talk about today. So if you look right here, we're going to talk about that is how you treat to reduce water pollution. So if you live in the country, you're going to use something called a septic tank system. If you live out in the city, stop. This is my little one, Sebi, by the way. He just had to sit with me. He's 20 months old. So if you live out in the city, for example, I put a city right here, your water that is polluted is going to travel eventually to a sewage treatment facility. And so, for example, in this picture you can see right here, if you are in the city, your house, for example, has a bunch of pipes that's going to deliver that polluted water. Or if you're like a business, same thing. A bunch of pipes are going to deliver that water eventually to a water treatment facility plant or a sewage treatment facility plant. There's a lot of different names you can associate that with. And eventually they'll clean the water and it'll make its way maybe back out to like a river, a lake, wherever it's going to go. So let's go ahead and get started on this. So we're going to start with looking at if you live out in the country. So if you live in rural or suburban homes on the outskirts of town, you might have what, like I said, is known as a septic tank system. So let's jump down here to this slide. And this is on Google Classroom, so you can actually go through this PowerPoint by yourself. And so anyway, so if you live on the outskirts of town, out in the country, you have a septic tank. So that's what we put right here. So you are considered rural or suburban, your home, your business, you probably have a septic tank. Okay. And what happens is that when you pollute your water inside your house, you are going to basically discharge that polluted water through a bunch of pipes until eventually it reaches into, like I said, a septic tank or a large drainage field. So this is from your packet right here. We're going to go through all of this, so there's no need to rush to write it. I would just write number 74 right now and 75. And so let's look right here. So anyway, so I would just write these two right here. And so again, if you live out in a rural, suburban home or business, for example, you are going to have a septic tank. So all your sewage from your house is going to go into the septic tank, and eventually it's going to empty out into a large drainage field. So this is number 74 and 75 of your packet. Now we're going to actually come back to this and we'll fill out the rest in just a moment. So let's go ahead and look at our diagram to see what a septic tank looks like in this drainage field. So we're going to go right here, and you can see right here, this is in your packet as well. That is on page 9, like I said. And what it is that here is your house if you live out in the country, and you can see that polluted water from flushing your toilet or from using your sink is going to go through a pipe right here, and it's going to eventually make its way into the septic tank right here. So this is a septic tank. So we're going to go ahead and delete that so you can write that term in. And if I go too fast, please just listen. You can go back and you can fill all this in by looking at the PowerPoint. So just listen, unless you write really that fast. All right, so the septic tank is right here. And we really want to understand, as the water is going through, how do we separate this water that's been polluted? And so let's go over here. So as the water comes through, the polluted water, that's this part right here that's coming through. So household sewage and wastewater is going to be pumped into your septic tank, which again is right here, and that's why they're pointing over here. And so as the water goes through this septic tank, let's think about what is going to float out of the water. And so think of things like gas is going to float. So gas would be on the top, which makes sense that you guys know that gas floats. What also floats? When you're cooking and stuff, what do you notice as you're doing dishes and so forth, what tends to float as well? And if you can think of it, you might think of something like scum. And you probably won't use the word scum. You're going to think more of things like grease and oil is going to rise to the top. So if you've ever done any cooking, you've noticed that grease and oil tends to ride and float on top of the water. And because of that, in your septic tank, these items up here get stuck right here. And you can see that they don't have a way to get out, which is really nice. Your septic tank doesn't allow them to get out right here. So instead, what is going to be able to get out is that partially treated water that has lost the gas and has lost that grease and oil and stuff. Now, what also it's going to lose, though, it's going to lose the heavier items. The heavy items are going to go to the bottom, and they're going to become what is known as sludge. Okay? And you can see right here, your septic tank only allows this partially treated water to escape. Right here, partially treated water can escape, where the heavier sludge and the grease and the oil and stuff stayed inside your septic tank. Okay, now your sludge, sometimes students like to know, well, what is technically sludge? In your book, it doesn't really say what it is. So I put some things up here for you guys to look at. They tend to refer to sludge as anything that is a solid, semi-solid, or liquid. And it usually comes from the household, commercial, or some kind of industry entity. It may be generated as a result of wastewater treatment, which we're doing right here. We're treating the wastewater. And it does not include coming out of a treatment facility plant. So it's basically when you're treating it, you're going in. And so just think of it like this. As your household sewage wastewater pumps in, it's the heavier things that are going to float to the bottom. That's technically the sludge. So again, it could be liquid, it could be a solid, it could be semi-solid. So just think of bigger things that are going to fall down there. So if you flush something down the toilet that is heavy, like maybe like a tampon or something, if it can make it through all those pipes and not get stuck, it could actually end up in your sludge, which could be an issue because some of that stuff might, depending on what it is, it might not be able to eventually deteriorate or decompose by something like bacteria. Because what's really nice in your septic tank is you have bacteria living here that's helping break down that sludge. And so you really want to make sure you're flushing things down the toilet that can be decomposed by bacteria that's living in your guys' tanks right here. Which is nice because just like your aquariums, we found out that everything basically has bacteria in it decomposing part of the food chain, food webs that are so important. So anyways, heavier things like sludge, again, are going to go to the bottom. And let's see what I put down here. I forgot. Oh yeah, solids will fall to the bottom, and then, like I said, the bacteria would decompose it. Now that partially treated wastewater that has lost all that gas, that scum, the sludge, it's going to now travel from your septic tank down to this distribution box right here. And your distribution box is going to distribute that wastewater out to the drainage field. And so you can see right here, it can go this way, this way, this way, all over down throughout here. And these are pipes that have little holes in them that allow that wastewater to be able to go through those holes and out to your drainage field. So this is your drainage field right here. And you can see your drainage field is made up of gravel or crushed stone. and the water will go in there and it kind of percolates down, and soil bacteria will be able to get rid of the last little bits of particulates, little particles that are that needed to be broken down. Like if some of your poop and stuff is made through like little tiny particles, bacteria and stuff will go to town and break that down out in this drainage field, and it allows it to kind of like space out. And anyway, so bacteria from all over this can go to town on it. Pretty cool. If you notice right here, these other pipes back here didn't even have any holes in it, and that's because we don't want your wastewater to be delivered outside of these pipes over here. We only want it to be delivered when it gets here to your drainage field, okay? And right here, this is just a vent pipe. I wouldn't worry about that. Just make sure you know that this right here, this drainage field has those perforated pipes that allow the wastewater to, again, go into that gravel or crushed stone right here, into that drainage field, okay? Very cool. And also down here, I have a little bit more about the sludge, what it is, so you can read up on it. It's the same as this. It's just put into a sentence. All right, so one other thing I should mention is, one other thing I should mention is that if you live out in the country, again, you have a septic tank system, is that over time, your septic tank system actually has to be pumped. To get rid of some of the sludge that builds up if it's not able to break down. And so they recommend that you have your septic tank pumped every 3 to 5 years. And what they do is they actually have a little manhole cover right here, and they open that and they stick a pipe in, and they can actually pump out the sludge and gross parts. I'll show you a picture of that right here. So right here you can see this gentleman right here, he is pumping. He has the manhole cover off of the septic tank system, and he's pumping out all that sludge and gross stuff. So you need to have this done every, say, 3 to 5 years. Some people don't have it done for like 20 years. The problem with that is if you don't, what's going to happen is that that sludge, if it gets really high, it could start to kind of it could come out and go into here, which would lead to your distribution box. And if it made it past your distribution box, just imagine like more solids filling up in here and stuff. And now solids could leak out into your drainage field. And if it's like poop and stuff, it would start to fill up, and you got water and poop and feces, which is poop and gross stuff coming in your backyard. And let's say if the sludge went back this way, if it got caught up here, it could go back into your house and start like stuff coming out in places and stuff. And we'll talk more about that. So it could be pretty gross. All right, so let's go into the next part. Go back to your homes on the outskirts of town. So basically what happens is that your household sewage, if you remember, and that wastewater is going to be pumped into what kind of tank? Septic tank. And what's going to rise? Grease and oil goes to the top, and the solids are going to go to the bottom, and bacteria is going to come by and decompose it. Number 77, the partially treated wastewater that results is going to be discharged in a large drainage field. So it's going to make it out to that drainage field through those small holes in those perforated pipes, which are embedded in the gravel or crushed stone, and all of this is just right below the Earth's surface. That's why you can't see your drainage field or your septic tank out in the backyard, because a lot of this is right below the soil surface. Number 78, as these wastes drain from the pipes and they percolate downward, the soil is going to filter out some of the potential pollutants, and it's going to decompose biodegradable materials. And who's decomposing it? Who lives in the soil? It's going to be bacteria. Very good. So let's talk about septic tanks a little bit more. So number 79, what happens if these septic tanks are not installed correctly and if they're not pumped out regularly? So if they're not installed correctly, if you remember it again, if you have like a hole in your pipe or something that you could you could start to have them overloaded, and stuff could start leaking places where it's not supposed to, smells gross, So anyways, they can cause your sewage basically to back up into your homes. And also, they could pollute nearby groundwater, surface water. Because remember, if it makes it out into that drainage field, you know, and rain and all that stuff, it can eventually overflood into, again, groundwater, other surface water, and pollute those areas. Gross. All right. So what happens though if, like, let's say you're at your sink and you're cooking and stuff, and you're washing the dishes, and then it starts to, you can see that you have water that's starting to come back up, and it's not draining properly. A lot of times people will use chlorine, bleaches, drain cleaners, right? They'll put that down there to help prevent that, to what should I say, from the water being able to come back up to, yeah, you guys know what I'm talking about. But basically, they are trying to use those drain cleaners to eat away at the stuff that's inside the pipe, like food and stuff, maybe like if you have a garbage disposal. And like my husband, he'll cut his potatoes. He used to, and he'd leave the skins in there, and he'd put it down the garbage disposal and turn on the garbage disposal. Well, that can overload your, if you live out in the country again, your septic tank systems. And that could be bad. And so people use drain cleaners and other things to eat away at that food, to clear out your pipes. The problem with that is that who lives in them? If we remember, down here, we talked about sludge. Who's going to decompose that sludge is going to be things like bacteria. Well, what happens? Oh, and bacteria out here too is going to be able to decompose stuff as well. But what happens if you put drain cleaners and chlorine and other things down your pipes is that you're going to kill off that bacteria, so they're not going to be able to get rid of this stuff as well. And that means the sludge stuff is going to fill up and stay longer, laster, and that, again, can cause your septic system to go back into your house. So the bad problem is that those can actually kill your bacteria that decompose the waste and cause your septic systems to be overloaded. So you got to be careful on using those drain cleaners and other things. All right, so what can kitchen sink garbage disposers do to the system? Like we talked about, they can overload your septic systems. All right, so we've already talked about what an effective septic system is, because we talked about you want things to flow properly. So as you use your sink, you want that water with the little bit of pollution you have in it from your food and so forth, washing your dishes or going to the bathroom. You want that to be able to flow properly to your septic system, septic tank, and then eventually out to your drainage field. But if you have any plumbing problems, if you have water or sewage coming up in your yard, strong odors and stuff, that again, that means your septic tank isn't being effective. So right here you can see in this person's yard, they are having problems with their septic tank. Something's going on. They have a problem there. And then this right here is where I talked about every 3 to 5 years. Again, you want to have your septic tank system cleaned out, pumped up, that sludge and stuff. So anyways, so what happens if you live on the inside of town? Well, you're probably not going to have a septic tank system and a drainage field. Instead, what you're going to have is you are going to have a bunch of series of pipes that are going to take that waste from your house, and they're going to deliver it to a sewage treatment plant. And so we're going to talk about that. So anyway, so if you live in urban areas inside the city, again, your waste is going to flow through a network of pipes to basically a sewage treatment plant. And that raw sewage is going to be treated with 1 or 2 levels of wastewater treatment. And we're going to talk about these 2 different levels. Okay, so anyway, so if you live inside the city, your water is going to go through a sewage treatment system. And, and so you should be on this page right here. And that means it's going to a wastewater or sewage treatment plant. And this is what they have. They either have 1 or 2 ways to treat it, sometimes even 3, depending on what country you're in, where you're from, and so forth. So your first box is actually above here, right here. Let's go to this page right here. So right here is the box that I want you guys to write in, right here, this first box. Okay. Whoop. And the first treatment is called primary sewage treatment. Okay, and I just put ST because I knew it was too long to write the whole thing out. So just write primary ST, and the ST stands for sewage treatment. If you write really small, go ahead, feel free to write it in. But anyways, so this primary sewage treatment is these three things right here. So go ahead and make sure you draw this little guy in right here. Okay, and we'll talk about this. This is the first treatment that your water will undergo when it gets here. The second one is called secondary sewage treatment. And again, you need to draw this little thing in. And it's going to be these three things right here. So the big difference between these two is that the primary sewage treatment is more of a physical process. So we're physically removing bigger items, and we'll talk about that. Where this one right here, the secondary sewage treatment, is more of a biological process. And we'll talk about the difference between the two. All right, so let's start with the primary sewage treatment. So over here in your box, which is actually down here, what you have coming from your house is raw sewage, right? It's coming from the sewers. And as it reaches here, just think about if you just cook pasta. If I just cook pasta, how do I get, let's say if we have water and we have the pasta in my pan, how do I get rid of what's polluted my water in this case, which is the pasta? What do we tend to use? Well, we tend to use, what is it called? Like a screen, right? What's another word for that? I'm drawing a blank. But anyways, you use your little screen. What is that called? Anyways, and you put that in the sink and you pour the pasta and the water through it, and it's going to separate the water and the pasta, right? Well, it's the same thing here. Is in order to bring this polluted water here, and it's got all these heavy stuff in it, we're going to use a screen to be able to get rid of that bigger stuff, like your bigger poop and stuff. That's more hardier. Don't mean to gross you guys out. But anyway, so we use something called a bar screen to get out the heavier stuff. Okay, so you can see right here as the water flow through, heavier stuff is getting stuck because they have a screen, and that means that the water that is going to be able to flow through, and it's going to have less of the heavier stuff in it. Okay, so anyway, so it removes large floating objects, that bar screen, which is really important. Okay, and then the next one right here, you can see as the water flows through, this picture is really great because it shows you all of it. You can see that we're going to start to slow down the water right here. And the reason why you slow down the water is because that incoming wastewater is going to be so slow that we can get rid of smaller things like sand and grit and small rocks and fecal material again, and so that can settle out. So just imagine your tanks, your aquarium tanks, is that when you add water, you'll see all that like sludge come up and start to flow. Ooh. And as it starts to slow, eventually it'll settle back down. So that's the same thing here. That's why they make it go slowly through this process, is so that those little particulates and stuff can kind of settle out. Gross. Anyways, right here. All right. And then it's going to go through this thing right here. Oh, and that is, again, that's called a grit chamber. Okay. And then it's going to go through the third thing right here, which is going to be called your settling tank. Another term, settling tank. Anyways, where your suspended solids are going to settle again. So it's again going real slow right here. And you can see the little particulates, the little suspended solids are starting to settle. And that is known again as sludge, which you saw before. And that sludge is going to accumulate down into here. And this is called a sludge digester, and it's going to take all that sludge and kind of put it together, and eventually now we got this sludge drying bed down here. Like, gross! All of this sludge is like, think of it like fecal matter and really gross stuff that is all like together. And what are you going to do with this? And well, if you're a farmer, you're going to say, well, we can use it on our agricultural land as a fertilizer because it's got some stuff in it that you can use. Or you might want to send it to the landfill. Those are the two ways that we get rid of this sludge. So that's where it's got to go, either agricultural land or to, like I said, a landfill. Anyways, so that is primary, secondary sewage treatment. And I also should mention on the AP test, when they asked this on the AP test, they asked for the primary, secondary treatment. They said, well, what kind of large objects does the bar screen or the grit chamber, what are they taking out? And so for the bar screen, we could say things like solid human animal waste, that tends to be heavier, twigs, cans, whatever kind of gets flushed down the toilet, condoms, tampons, fruit. They accepted all of this on the AP test. So just imagine something that you could flush down the toilet that eventually would get caught by a bar screen. Now the grit chamber is where you want to more talk about sand, small rocks, fecal material again. So anyway, so sand, small rocks, that'd be more of the grit chamber. Okay, so that's primary, secondary sewage treatment. Let's move to the biological one. So now the water has gone through here. It's lost a lot of sludge from it. And we're going to enter this next secondary sewage treatment. The first tank it's going to enter the aeration tank. And basically what we're doing is we're pumping it full of air. Why would we pump it full of air? Pump it full of air because who is going to use the oxygen to break down any of those floating gross stuff in there? And it's going to be bacteria. And if we learned about bacteria, aerobic bacteria needs oxygen to be able to break down and decompose that stuff. So anyway, so that's what we put here. And I know it's kind of hard to write right here, so you might have to write somewhere else and draw an arrow here. But anyways, they use this on the AP test. They refer to the stuff that was coming through that water as effluent, which is liquid waste or sewage now, that is going to come in contact with the oxygen and the aerobic bacteria, and it's going to be broken down. So anyways, right here, so you can see the little bubbles behind this showing that they're aerating the tank. They're putting oxygen in there. And they're also going to put some activated sludge can go in here so the bacteria can help break it down and so forth. Anyways, and that came from here and so forth. Don't really worry about that yet. So we'll talk a little bit more. So as you go through now and it's been aerated, bacteria is starting to break down, more stuff there. We're going to get to the next tank, which again is called another settling tank. And it's going to go really slow here so we can settle out more of that gross sludge and stuff. And again, that sludge stuff is going to make its way down to the drying bed. And we still have to get rid of all this sludge waste. But anyways, then the next one, it's going to go through the third tank, which is called your chlorine disinfection tank. Which is interesting that they put that right here, because we'll talk about it as also be considered a third type of treatment, but they put it in your book here, so we'll bring it up here. And this is the chlorine disinfection tank. And this is where they're going to basically put chlorine in your water. And they do that to change the color of it, because people don't want to drink water that looks gross. And also to kill pathogens, right? So nasty things. Pathogens, anything that's going to cause you, that can make you sick, cause diseases. Anyways, so right here, the chlorine is going to kill bacteria, pathogens, and so forth. And eventually that water now can make its way to a river, a lake, or ocean. Woo, that was a big process, wasn't it? Some other things that we'll talk about this right here, this secondary sewage treatment, is it removed the dissolved or suspended organic material. So anyways, that smaller little floating stuff. And on the AP test, they might ask you what are some examples of things that it was removing in this process right here. And you need to say things like human waste products, soaps, detergents, food waste, pathogens like E. coli, and your phosphates and nitrates also got removed here. Not all of them, but some of them got removed here as well. Because you'll have some bacteria, let's go down here, that is in this system that can change those nitrates back into something less harmful. Anyways, so you have denitrifying bacteria. For your phosphate, the way it gets removed is they'll put lime or aluminum sulfate, iron chloride, iron sulfate, biological removal. So basically, they're doing some other stuff to remove that phosphate. Now, they don't always do this, depends on what country you lived in, how much money that facility has, and so forth. But anyways, all right. So that's a bunch of stuff that we learned about. What else do I have here? Oh yeah, and this just tells you that that sludge drying bed, is disposed of in landfills or the ocean, or it can be applied to cropland, pasture, or rangeland. Anyways, you need to know that for the AP test too. They wanted to say, well, why is these sewage treatment facility plants, what do they produce? And that can be harmful for the environment, and you would talk about this sludge. Because remember, not all the nitrates and phosphates get removed, so if it's in this and we're using it as fertilizer, eventually, remember, that can lead to algae blooms and stuff all over again. All right, so let's go down here. I like this picture because this kind of shows you a wastewater treatment plant, and if you can remember, it goes through the primary sewage treatment, then it goes to the secondary. This almost technically for us goes together. But again, depends on what facility, where you're at, what country, how they have them set up. And then I like this one because it has the chlorine tank kind of separate, because even though it showed it together, sometimes it's separate, and we'll talk about that. So anyways, so let's go over here. So how do sewage treatment plants create a solid waste problem? Well, remember that sludge, right? So anyway, so a better definition that they liked on the AP test is they wrote that particulates and other substances removed from wastewater during primary and secondary treatment create a significant amount of solid material. So remember that sludge created this bunch of this solid material, like waste, and we had to dispose of that elsewhere. So anyway, so just remember that these solid waste accumulates in that sludge. That sludge is basically the solid waste, and it's got to go somewhere. Okay? And where are the two common methods of disposing it? If you remember, how do we get rid of this sludge, this solid waste? Is either we're going to put it on agricultural lands like we talked about, or we're going to transport it to a landfill. Okay? So those are two places where we would dispose of it. But what's an environmental problem with disposing it, these two different waste methods? Okay, so if we transport to a landfill, you on the AP test, could you come up with some ways why that would be bad? To take this sludge and take it to a landfill, how would it hurt the environment? So how could this sludge hurt a landfill and eventually, in a sense, hurt the environment? So what would be some problems that we'd run into? On the AP test, can you come up with at least one or two or three? So I have them underneath here. I'm just going to give you a second to kind of think about it. Okay, so here is some problems with the landfill. Number one, it takes up a considerable amount of landfill space. Duh. All this sludge is going to take up all this space at the landfill that we might need for other waste. Okay. What happens if that sludge gets contaminated? Potential groundwater contaminations. It could still have some stuff in it that's not healthy for the environment. It can lead to toxins, contaminants, gets into the groundwater, maybe if it had a huge rain, and that could be detrimental to the environment. Also, greenhouse gases such as methane produced during anaerobic decomposition can escape into the atmosphere. That can contribute to global warming, and environmental effects associated with transportation of solid waste. You think about how you are transporting that solid waste, and because you're using a car or a big car or truck or something like that, you are releasing carbon dioxide, which is contributing to global warming and so forth. So even just driving it and dropping it off is a problem to the environment as well. What are some agricultural problems? Can you think of a couple? You might see this on one of your tests. Human and animal health problems associated with bacteria waste, contaminating food crops. So that sludge might have stuff in there that is not healthy for the little critters that are going to come and eat it, and they get affected, or we eat it, and so forth. Potential groundwater, soil, water contaminants, and all of this stuff. Okay, so make sure you read, you study these, you know them. I know this is not in your packet, but I'm telling you, you will see this on a test. All right, and let's go on to the next one right here. All right, so for the primary sewage treatment, a little review. Remember that this is a biological or physical process. It is a physical process. And what do we use? We use, remember, think about if you're making pasta, we use screens, right? And a grit tank to remove large floating objects, like big poop, you flush a toilet down, a toy down your toilet. Anyways, and it's going to allow those solids such as sand and rock to settle out as you go into the settling tank. Then the waste stream flows into a primary settling tank where there was nothing supposed to be here. That was a mistake. Where suspended solids settle out as sludge. So go back, review that, make sure you understand that process. By itself, primary treatment involves about 60% of the suspended solids and 30 to 40% of the oxygen-demanding organic waste from sewage. So what this is saying is that we're getting out a lot of the heavier stuff, even the suspended stuff, the smaller stuff, but we still have some stuff that needs to be removed. That's why it's important to go to secondary sewage treatment. And we're getting rid of some of the oxygen-demanding organic waste, but we still need to get rid of more, and we need bacteria, and we need oxygen. So that's why, we got to go to the secondary sewage treatment. That's why it's important for a plant to have both sewage treatments. Okay, and so what does this primary sewage treatment not remove? Hopefully you remember. It doesn't remove phosphates, nitrates, salt, radioisotopes, trace amounts of medication, which we didn't talk about, pesticides, or pathogens, such as viruses. Pathogens are things that want to make you sick, cause you diseases, okay? So anyway, so it doesn't remove a lot of this stuff right here. This does not remove. They might ask you on the AP test what is not removed. You need to be able to say some of these things, okay? So that's why it's important, again, to have secondary sewage treatment. So this one is a biological process in which we're using that aerobic bacteria. Remember, he needs oxygen. That's why we got to aerate the tank. And he's going to remove as much as 90% of dissolved and biodegradable oxygen-demanding organic waste. So what this is saying, it's getting rid of a lot of that excess stuff that's in the water that is polluting the water. Almost 90%, it can get rid of all this oxygen-demanding, you got it, all that stuff. Pretty cool. All right. Now, primary and secondary treatment together, a combination of these guys, you can see, removes basically all of those suspended solids in the water and oxygen-demanding organic waste. And you can see it removes a bunch of other stuff too. 70% of the most toxic metals. That means there's still toxic metals in it. Other bad stuff for you. And it also removes non-persistent synthetic organic chemicals, 70% of the phosphorus, and 50% of the nitrogen. That means right here, we didn't get all of the nitrogen and phosphorus. So that means that if you just release this into the water, into the ocean, you can again have a chance of having algae bloom. And so that could be bad. That's why it's important to have the next treatment, which we'll talk about. Anyways, but it does remove some of it in the secondary sewage treatment, not in the first one. Okay. However, this process removes only a tiny fraction of the potentially persistent and potential toxic organic substances found in some people's pesticides and in discarded medicines that people put into their sewage system. Don't dump your medicine down the sewage, down your water. Anyways, and it does not kill pathogens. This part is a little confusing because on the AP test, it did allow you to say that the secondary sewage treatment did kill some pathogens on the AP test, but on here in your book it said it didn't. But on the AP test, it did say that the secondary sewage treatment can kill some pathogens. So that's a little confusing. Because if you notice that they had chloration in our book under secondary sewage treatment. And if we're putting chlorine in there, that can kill some pathogens. So it can be a little confusing. So on the AP test, realize secondary sewage treatment can kill pathogens. Chlorine might be part of that secondary sewage treatment. All right, so a third type of cleanup, advanced or tertiary sewage treatment, is basically using chemical and physical processes to remove specific pollutants left in the water after primary and secondary treatment. Okay, so basically they're using special filters to remove the last items that we talked about, those phosphates, those nitrates. This third cleanup can really remove most of those right now, and right before the water's discharged into other waters. So anyways, so it'd be really nice to have that third treatment, but a lot of facilities do not have it. So anyways, that sucks. So is this stage used a lot? Why is it helpful? So do you think it's used a lot? No, it's not. Because it costs a lot of money. And would it be useful? Yes, because we're reducing those nutrients that can cause algae blooms. So we're reducing the nitrates and phosphates. So it would be nice if we could use that. All right, before discharge from treatment plants. Water from sewage treatment plants usually undergo what? So the last thing, if you remember, it undergo was disinfection, or you can say chlorination. So anyways, disinfection or chlorination. And what they do is basically they bleach the water. Why do we bleach the water? Is because it's going to remove coloration and it's going to disinfect, kill pathogens. So again, I've seen them refer to this as chlorination. In your book it does. But I also threw in disinfection because they referred to it as that as well. Disinfection being the last step. So anyway, so we kind of referred to both. Okay. So how can chlorine be bad? You can read right here that it can react with organic materials in the water. Basically what it can form is chlorinated hydrocarbons. And those can cause cancer. They can cause miscarriages possibly. Damage to your nervous system. They can disrupt your immune system, your endocrine system. Remember a few of those, okay? Not all of them, but a few. So chlorine can be bad for us. All right. What can be used instead of doing chlorination? So instead of doing chlorination, what can we do? You can use disinfectants like ozone, the O3. You can also use ultraviolet light that can also kill off and do the job of chlorination. The problem is that it costs more to do these two things, and their effects do not last the same as adding chlorine to the water. So it's a predicament there. Anyway, so don't forget, because on the AP test they did ask for disinfection. What could you, what's part of this process? And it could be using ozone, and it could be using that ultraviolet light as well, besides just bleaching. So anyways, and adding that chlorine. So make sure you put that in your head too. Ozone 3, remember O3, and the ultraviolet light, but it's costly. All right, so before discharge from the treatment plants, what is the federal law with regards to primary and secondary treatment in the U.S.? Basically, you have to do both at our facilities. Both are required in all household sewage treatments in the U.S. But does everyone follow this, or are there exceptions? Explain the exceptions. No, some towns, cities that can show that the cost of installing these systems poses an excessive financial burden to them, then they don't have to do secondary treatment. So they might just do primary treatment. And if they're not doing secondary, then think in your head. That means their water is going to release more nitrates, more phosphates. Remember that medication, pathogens, all of that. So it's really important to have both, but people can get away with it. Cities, towns can get away with it if they show excessive financial burden. Think about also other countries that can't afford this. Anyways, does every city follow the rules and regulations? If not, explain. So you can see right here that the EPA said that 2/3 of the sewage treatment facility plants violated water pollution regulations. 500 plus U.S. cities have failed to meet the FEDG standards. 34 East Coast cities simply screen out large floating objects. That means they get the large stuff out of the water and then they just discharge it into the Atlantic Ocean. Gross. That means you have a lot of stuff in that water that is going out. Think about the algae blooms and stuff again. All right, so what are 3 ways to improve conventional sewage treatment? Number 1, require all industries and businesses to remove toxic hazardous waste from the water before it's sent to these treatment facility plants. So if they're removing some of this toxic hazardous stuff, that would be better for the treatment facilities, especially if they don't have primary and secondary, or the third one, tertiary. Number 2, encourage industries to reduce and eliminate their use and waste of toxic chemicals. So use less things that can be toxic that's polluting the water. And also, number 3, you could say composting toilet systems. So remember, our toilet is flushing down and it has that nitrogen, phosphorus, and all kinds of stuff in it. And if we were able to use composting toilet systems, and we would not use water so much, no, we wouldn't pollute the water, but also we could turn that fecal matter into a fertilizer, right? Because you've heard of people doing this using composting toilets. Then they'll take eventually that sludge and they'll use it on their gardens and so forth and other places. Or whatever. Maybe not their gardens. They could. Anyways. So that's it. I hope that you guys, if you have trouble, if I went too fast, please make sure that you look over this and you go through it, listen to it again, take time to write all the stuff out. You can see my little guy over there eating, snacking, and see if I can show you my daughter real quick. Let's see if I can show you her. There she is. And anyways, so that's it. Good luck. Make sure you study chapter 20 and you feel good, or watch this over again. Make sure, can you write both of these out on paper? Do you know the difference between the two, and so forth? So other than that, I'll see you guys later.